My name's Jordan, manager of RAECO Rents here, and this is Randy, our salesman to the right of me. He will definitely be meeting you guys at the student night, so keep an eye out for him. And any questions you guys have, anything you want to know, you can ask him. He'll answer it or he'll forward it on to me. So first thing that I'll go over here is just some basic single gas monitors. So the most popular sensors are going to be carbon monoxide, carbon dioxide. We see those all the time for indoor air quality assessments, things like that. And then, of course, sometimes other things come up. So there are a lot of sensors available for these. And this instrument is called a ToxiRAE Pro. So it's a small, wearable, handheld, single gas monitor. And we say diffusion style because there's no internal pump here that's drawing in a sample. So it's only detecting air that's passing over that sensor. And here's just a little list of the sensors that are available for the ToxiRAE. You can see there are many, some with different specs. That's another thing to just think about when you're doing IH work. What sort of levels of a certain gas, in this case, am I expecting? Or even what resolution do I need? So some people will refer to resolution as accuracy sometimes. So for example, this hydrogen sulfide sensor listed here, 0 to 100 parts per million, it can read in increments of 0.1 parts per million. So it's got a little bit more accuracy or resolution. And there's some more sensors here that are available for the ToxiRAE. Again, just making you aware of the capabilities here. And now we'll move on to the Q-Ray 3. This is a 4-gas monitor made by the same manufacturer, typically used in confined spaces. A lot of time people in construction are using these, but there's a lot of different applications for it. Anytime you're looking to detect these gases, it's when you can use one of these. The important thing with this is that it does have a pump. So before you go into that confined space, you can hook up some tubing to the Q-Ray, drop that down, and wait maybe 30 seconds to a minute for that air to come up into the sensor and make sure you're getting accurate readings of what is down in that space. So that's just a basic safety thing, making sure you're going into this confined space and that you're going to be safe in there. And we have just the standard 4-gas sensors on it, which is your CO, oxygen, hydrogen sulfide, and the LEL sensor, which I'm not sure if you guys know, but the LEL is lower explosive limit. So that's going to give you a reading in percentage of that limit. So you won't get like parts per million like you would with carbon monoxide or hydrogen sulfide, but typically that's measuring methane, and it can be set to measure other combustible gases. So, just another thing to think about, if there are combustible gases like methane or propane, pentane, just to name a few, you can adjust the sensor to respond to certain gases in that way, kind of similar to a PID, which we'll go over later, but you guys might know about that already. So just a quick little summary of the capabilities of them again. Very good data logging capability. Sometimes people are worried about how much information can this unit store. So the ToxiRAE and the Q-Ray both have very large data logging capacities. Pretty good battery life. The ToxiRAE is up to 30 hours, which probably won't have any battery issues with that. Since that Q-Ray does have that internal pump though, and 4 sensors, that's draining a lot more battery. So look at about maybe, 10, 11 hours on a good Q-Ray battery. They are water resistant, so don't be dropping them in the water, but if they're getting sprayed a little bit, that's okay. And as far as humidity and temperature, you pretty much don't need to worry about that. They're suitable for most environments. All right, so some people may ask, when can I use passive sampling, or when might I need a pump? Kind of went over this a little bit before, but leak detection in confined spaces, you're definitely going to want to use a pump. You've got to make sure that you're pulling that air, trying to find the leak in this case, or, from the confined space, pulling that air up and making sure that there's safe levels of gases down there. And, some people may call it like active versus passive. So the ToxiRAE, the little single gas monitor, that's your passive. And then the Q-Ray or some other pumped instruments can be considered active. So my preference is always to just use something with a pump if you can. If you don't need it, then and that's okay. All right, another important thing to look at here, I think I screenshotted it, yes, is cross sensitivities on sensors. So these are electrochemical sensors, and they can respond to other gases. So you can get some false readings. And there's positive and negative cross sensitivities, so it goes both ways. And there's a good technical note. This is a clickable link, so you can pull up that technical note from the PowerPoint here. But this is just an example. So again, this is carbon monoxide, the most basic sensor that we have. So it doesn't have too many large cross sensitivities. There's a lot listed here, but the main one is isobutylene. That's what people use to calibrate PIDs. So you'll see if you were to use a multi-gas monitor that had a PID sensor and carbon monoxide, you would see that carbon monoxide jumping up if you ran this isobutylene across the sensor. So yeah, just something to look out for. If you're saying, hey, I want to start measuring carbon monoxide, technically, if you're using this, you've got to make sure that you don't have these cross-sensitive compounds in the area. So just something to think about. Always keep that in the back of your head. Oh yeah, there's a carbon monoxide sensor. They make a hydrogen compensating carbon monoxide sensor, and that can be used in a ToxiRAE, other RAE instruments like a MultiRAE. So it'll compensate the reading for hydrogen. And you can see in this sheet here, 100 parts per million of hydrogen is going to get you a reading of 40 parts per million carbon monoxide. So that's the reason for this hydrogen compensating sensor. A big application for these is charging batteries. If you're somewhere where they're charging a lot of batteries, that produces hydrogen. So that's when you're going to need this sensor. And there's a look at it. So you can see at these much higher concentrations, you still do get a response with hydrogen, but it's a lower response. Okay, so for the ToxiRAE Pro, there is also a different instrument, the ToxiRAE Pro PID. So this is your personal wearable PID monitor. So just like anything else, it's going to detect your VOCs, and you can select a correction factor from a list of compounds. So if you know that you're measuring propanol or something like that, you can go in here, select that correction factor, and then it's going to be responding to the propanol, or have the correct correction factor for propanol. And I'm sure you guys probably know this, but very important to note that a PID is not specific. So it's going to respond to any volatile organic compound. All right, so these are more robust PIDs. These ones are handheld. There's the MiniRAE and the PPB-RAE. And they're very similar. We can bring up the concept of, resolution again. So the MiniRAE has a resolution of 0.1 parts per million. The PPB-RAE has a resolution of 1 part per billion. So it's got a much, much more precise sensor. They can use different lamps. So different electron volt lamps can detect different compounds. Some just don't have the capability of detecting others. It depends on the IE, or I believe it's the ionization energy of the molecule. So, again, that's something to think about if you're using a PID, what lamp can detect it, what can't. And there are resources for that. So here is one of them. So this RAE Technical Note 106, that's going to show you the compound name. It's going to tell you what the IE is. And it's got in parentheses electron volts. I guess you've got an 11.7 lamp, which is considered 11.7 electron volts. So these kind of go hand in hand. So for the highest accuracy, you do want to use a lamp closest in the ionization energy to the compound that you're detecting. And at the very least, the lamp should be higher than that. So, iodine, I guess, has 0.1 for everything, but it has a 9.4 IE. So the 11.7 would probably be the most accurate for that. And you can see all the different correction factors in there too. So again, just, information on PIDs to know about. You guys may know about this already. Okay, and yeah, this is a link to that technical note if you want that. There's also the NIOSH Pocket Guide to Chemical Hazards. That's something one of our customers really likes, so we threw that on there. Okay, so this brings us to the MultiRAE. So the MultiRAE uses the same sensors as a ToxiRAE. They are interchangeable. And the MultiRAE is basically, it's kind of like a Q-Ray and ToxiRAE all in one. It's got a PID sensor in there by default, and then it has a standard 4 gas sensors. So your carbon monoxide, hydrogen sulfide, LEL, and oxygen. We can also swap that PID sensor for a carbon dioxide sensor. So if you don't need the VOCs, but maybe you want to pick up CO2, instead of getting you, for example, like a Q-ray and a ToxiRAE, you can get it all with one instrument with the MultiRAE. And this is another pumped instrument. So this is pretty commonly used in confined space applications as well. It's also used in IH. So, like NO and NO2 sensors we see going in here a lot, chlorine, ammonia, things like that. And then we have the benzene equipment. So benzene is a very, very dangerous compound. For that reason, when you're picking up, when you are hoping to detect benzene, you need to use what they call benzene separation tubes. So basically this tube filters out everything that is not benzene and takes a snapshot reading of the concentration. Now they are single-use tubes, just something to note. But each of those tubes is needed to get your benzene concentration. So just kind of laying out everything here too. There's several different MultiRAEs. There's a MultiRAE Lite, there's a standard MultiRAE, a MultiRAE Pro, and then this benzene monitor. Important to note, some of them use different lamps, pretty much just the benzene model, but and there's also the changing resolutions here too. So different jobs may require different levels of precision. So important to know, what your needs are to make sure that you get the right equipment. All right, and here's just another list of the sensors that you can use in a MultiRAE. They even have a gamma sensor, which I've never used, but pretty interesting that they have that.
Jordan, I have a question already. Could you repeat the Q-ray? Does the Q-ray have a VOC sensor in it?
The Q-ray does not. The Q-ray is just kind of your standard 4 gas right here.
Got it. Yeah, and I agree that NIOSH Pocket Guide is super helpful for exactly this discussion.
Yeah, people in the field love that little pocket guide.
Yeah, we haven't gone over that, but I'm glad you mentioned it, and we'll keep it as a resource.
Mm-hmm. Yeah, and there's a link to it in the PowerPoint, so you guys have that. Let's see. All right, yeah, more of the sensors here on the MultiRAE. They've got lots of them. And you can see some of them are, for example, this one is only for use in the diffusion model. There's a few caveats, but most of them are interchangeable. All right. So let's go to kind of the logistics of sampling with this, your data logging. So if you were to rent the equipment, we just set them to automatically data log every minute. So once you turn that on, it's going to be data logging. You can set that to automatic or manual. There are user-defined data logging intervals, so you could have it measure every second, every 5 seconds, every 10 seconds, every 10 minutes, totally up to you. And then the data can be downloaded from ProRAE Studio software. Let's see. Oh yeah, you can also, if you're monitoring for some things and you don't need that data, or maybe a sensor's not calibrated, you can turn off those installed sensors. That'll give you some extra capacity for data logging if you happen to need it. So another little tip. So this is a video on how to download the data from ProRAE Studios, from a ToxiRAE or a QRAE or a MultiRAE. Julie, do you want me to play this video, or do you want them to maybe watch this on their own time?
You could, it'd be worthwhile to play it because that is part of what they're going to have to do.
Okay. Yeah, we'll
And that
go
way,
ahead and
if they
play
have
it.
any questions about it, we can ask questions now.
Mm-hmm. All right, let's get this pulled up here. And look, it takes you to our website. So it's just a YouTube video. All right. And can you guys hear that?
No.
Oh, you can't?
No, and maybe we'll have to skip it because I have found that what I've had to do to play videos with sound is I've had to exit presentation and then toggle a button so we can hear the sound and then enter it back in.
I have an idea.
Okay.
And
it's 12, it's close to 13 minutes, so I don't know if we want to
oh
hear
yeah,
the
it's a
whole
long
thing.
one. Let's just see if this will work.
Sure.
Do you hear that now?
No.
All right. We'll worry about that a different time.
Yeah.
But yeah, this is you can skip most of it. Some of it's just the installation process. But just pulling the data is maybe just a few minutes of it. It's also a little longer because we go over the process with 3 different instruments. So it's slightly different for each of them, but also very similar. So if you kind of watch one, you'd get the gist of all of them. All right, let me pull this back up. We'll get back on track. Okay, and everybody can see what I got here. We're all good again?
Yes.
Okay, good. All right, so with these direct reading gas instruments, a few things to think about, which I kind of mentioned earlier, but, are we doing personal or area monitoring? What is the range of the measurements? Is the instrument sensors going to be within that range? Every once in a while, it doesn't happen very often, but every once in a while, someone will rent something and then they realize that their readings are well out of the range of the sensor. So just always keep that stuff in mind. And of course, your calibration. If you were to rent equipment, we calibrate this equipment right before we send it out. So everything's going to come freshly calibrated. But if you own your equipment, if you're in the field using it, definitely want to make sure that you at least do a 0 calibration and a span calibration. The time periods on that are very up in the air with most people. It's kind of interesting. Any manufacturer is going to recommend that you bump test daily. A bump test is really just running gas over a sensor to ensure that it's responding to the gas properly. So that's going to make sure that it's responding, but it's not necessarily going to make sure it's responding with the correct concentration. So my recommendation is to do a zero calibration and a span calibration at minimum once a month. I would recommend it more often as a best practice, but at minimum once a month on these. All right. So for the zero calibration, you can use 20.9% oxygen, which is considered zero air. You can also just go outdoors and do what they call a fresh air calibration. Some people don't like to do that, but if you're outside, you're not near any industrial processes or anything like that, you're probably going to have pretty clean air. And so you can zero those sensors outdoors. And then we do the span calibration, which is running, a certain concentration of gas across the sensor. Ideally, you're using the manufacturer's recommended calibration gas. And for the RAECO products, that sheet that I had up earlier with the cross sensitivity, that's basically a spec sheet of every sensor, and it will show the recommended calibration gas to use as well. So the span is making sure that 100 parts per million is 100 parts per million on the instrument, for example. And then again, the bump test, important to know, it's not a calibration. It's just validating the response of the sensor. So you're just going to get a pass or a fail on that. It's not going to adjust the readings of the sensor in any way. Only your zero and span calibrations will do that. Okay, so now we're moving into indoor air quality. Before we do that, though, does anybody have questions on the gas monitors?
We haven't calibrated our gas monitors yet. We haven't calibrated our noise monitors yet, but we will be calibrating both. So this would be a good time if anybody has any questions.
Okay. All right, no questions? We'll keep going.
Sounds good.
Okay. So typical IAQ. We have this multi-parameter meter, the TSI VelociCalc 9565. You may have heard of it before, referred to as a Q-Track. It's pretty much just a newer, different equivalent, a little more versatile than the Q-Track. So when used with the 982 probe, it's equivalent to a Q-Track. And that's the most common indoor air quality equipment that I see personally is the VelociCalc with the 982 probe. That's going to measure your carbon monoxide, carbon dioxide, and temperature and relative humidity as well. So if you ever need to measure air velocity, you can do that with the same meter, the VelociCalc, and then just rent or purchase, whatever you're doing. Make sure you've got the applicable probe. So there's a couple of options with the VelociCalc. There's the 964 probe and the 966 probe. They're both going to measure the same thing, being temperature, velocity, and relative humidity. But the 966 probe is an articulating probe. So you can bend and rotate that. They're both telescoping probes, so you can extend them. But if you're measuring in ventilation and you need to kind of get at a certain angle, that 966 probe is what you're going to need. There's also a 995 probe. That's a rotating vane probe. That's the big one here that you can see right next to the VelociCalc. It's like a fan. So that can also be used for getting your velocity and I believe just temperature readings. I don't think it does humidity. So you can also get pressure measurements with this. There's a 9565-P, that's what we carry, and it has a built-in differential pressure sensor. So you can actually get static and differential pressure measurements. Again, in indoor air quality, most people will be using that. They're looking at pressure, you know, indoor versus outdoor, stuff like that. All right. And more indoor air quality equipment, the TSI Quest EVM7. This one is one of Randy's favorites because it does so much. And the TSI Q-Track XP, based on what I've seen, kind of seems to be their replacement for the EVM7. So I think moving forward, they'll be phasing out the EVM, and the Q-Track XP is probably going to be what you guys will see.
So Jordan, I will add that we have it in our room. We have both the EVM7 and the TSI Q-Tracks, and I would expect, as long as there's enough of them to go around, I would expect that everybody would probably choose this one to do their sampling after noise.
Which one, the Q-Track or the EVM?
Probably, I think we have a handful of TSI Q-Tracks, so that would be the most likely one. I've put my eyes on at least one EVM7, and that one also looks good for what I think they're going to do.
Yeah, you guys don't have this new one, do you? The Q-Track XP?
I think we do have at least. What model is it?
That's a 7585.
Yeah. I'm gonna go look in my notes and I'll put it in the chat. But yeah, we might.
All right. Well, here's what we've got with those. So they're both very versatile. The EVM, first of all, it's going to log all these data points simultaneously. They're both capable of that, the EVM and the Q-Track. So one good thing about the EVM, it does have gravimetric sampling capability. So in the back of the unit, you can put a cassette in there. You can take a sample and get your gravimetric sampling done in addition to your real-time monitoring. So you've got gravimetric, and you also have real-time particulate monitoring. And it has what they call, I think they call it a rotary impactor. Basically, the little red dial here on the upper left, that's the impactor. And so when you rotate that, it's going to change what you're measuring, whether it's total dust, PM2.5, PM4, PM10. It also has a carbon monoxide, carbon dioxide, and PID sensor in there. It's got temperature and humidity. So with one instrument, you're measuring temperature, humidity, CO, CO2, your volatile organic compounds, and your particulates. It also provides dew point. So that's your 7 variables, and that's your EVM7. So the good thing about this too, just if you happen to be using other noise equipment or other Quest equipment, really, it uses the same software as all of their noise and heat stress equipment. So if you happen to be doing other sampling with those, it's just nice that it's one software with everything. So the Q-Track XP, this thing's pretty new, almost brand new. I'd say maybe a year old, almost at this point. This can simultaneously measure all those particles. So your PM1, PM2.5, PM10, and total dust. It may do respirable as well. I think that's missing here. But the EVM, because it has that impactor, it can only do one of these sizes at a time. Your Q-Track XP can do them all together, and it does have the same gas sensors as well. At least with our configuration. There are other sensors. For example, they have an ozone sensor for the Q-Track XP. They have a formaldehyde sensor. There's quite a few out there, but we have just kind of stuck with this to have it kind of match the EVM7 for our purposes. A lot of people like that big color touchscreen user interface too. It does this thing's, it's handheld, but it's a big handheld. So it's a pretty big touch screen. What's really cool is you can see graphs of your data as it's being recorded, which is pretty nice. People just like to see those diagrams. And then of course you'll get a summary of your data, like minimum, maximums, time weighted averages, all that stuff.
So Jordan, I did verify, yeah, we had at least one of those in the field with us, and it was 14 different channels. And we duplicated some of the channels just for comparison of the sensors. I think what we duplicated was the carbon dioxide and the carbon monoxide, but and I don't even remember all the other sensors that we used, but we used like 14 of them.
Yeah, the Q-Track can do a lot. It's so a big part of that too is something I forgot to mention in here, but the Q-Track can measure your concentration of these particulates, and it can also get you particle counts. So just, each one of those is 2 variables for each particulate size. And that, you can do them in different units, milligrams, micrograms per cubic meter, all that fun stuff. All right. So do anybody have any questions on those two before we move on? Okay, we'll keep on going. All right. So for area dust monitoring, some people could use an EVM because it does have that particulate sensor and it's got a pump. So in a way, it's equivalent to this instrument, which is the DustTrak 2. There's 2 different models of DustTrak as far as just a standalone unit. There's the DustTrak 2, which is model number 8530. And there's the DustTrak DRX, which is the 8533. Now, we pretty much only carry the DRX. I consider it the deluxe model. It can measure all of your particulate sizes, PM1, PM2.5. See, I probably have this here. Yeah. PM1, 2.5, PM4, PM10, and total dust simultaneously. So it's going to give you all of those readings in real time. It's going to log all of it. It can do everything you need. Similar to the EVM, the DustTraks do have an internal option for using a cassette. So you can get a sample with that, send that off to a lab. It is important too that you use the correct impactor with that still. So if you're using the DRX and a cassette, make sure you're using the right impactor. If you're using the DustTrak 2, it can only measure one size at a time. So at that point, it's very important to make sure that you're using the correct impactor based on what you're sampling for. So PM4, PM2.5, those seem to be of interest to our customers the most from what I've seen. And there is an EP model. Whoops. There's an EP model of both of these. It just stands for external pump. So that's, if you see this picture on the left here, that model has the external pump hooked up to it. And you'll see there's 2 cables. One of those is just for the flow of the air. The other is to power the pump. So the pump gets its power from the DustTrak itself. And those are really just used in more long-term applications, like maybe 24-hour monitoring during construction, things of that nature. So you probably wouldn't be needing this for any IH purposes as far as the external pump goes. All right, so next one, which may be more useful to you in the IH world, is the 8534.
Yeah,
so,
we do have a DustTrak at present, and we might be sampling for dust.
Perfect. Do you have a handheld or?
Yes, the handheld, yes.
Okay. So yeah, I don't know. Do you have, it could be a DustTrak DRX 8534, or it could be the handheld DustTrak 2 model, which I forget what that model is, but
Yeah, I don't remember either the details.
yeah. But so the DRX, the 8534, this is the handheld model. So it's pretty much identical to the one that we saw before, but it does not have a spot to put a cassette in for gravimetric sampling. So it'll still measure your different particulate sizes and total dust all simultaneously without the use of impactors. It is important to note for all of these, though, that the flow rate should be set well, by default, it's 3 liters a minute. So if you want it to perform properly and read accurately, this should be calibrated at 3 liters per minute. And when you do that calibration, this PM 2.5 impactor should be hooked up. So if you browse through a manual, you would see that. Just a little note, if you guys are going to calibrate the flow, make sure you're using that PM 2.5 impactor. Okay. All right, so now we can go to personal dust. So this is another TSI instrument. It's called a SidePack AM520. And this is basically, you could compare this to a personal DustTrak 2. So this is a personal dust monitor that can measure one particulate size at a time based on the impactor that is used. And again, this can data log. It's got real-time measurements. So you'll see on the screen here, the real-time measurements displayed. If the levels do go high, you can set alarms on these, which is something that I failed to mention. But the DustTrak, everything I've gone over today, the gas monitors, the DustTraks, the side packs, you can set alarms on these. And if an alarm goes off, the screen will start flashing red. You might hear an audible noise. It depends on the settings, but you can adjust those alarm settings. For example, like vibration and a flashing light, or an audible noise. There's different combinations, but just know that you can set alarms on these and it will alert you accordingly. All right, and that's me posing for a nice picture here. Another thing, so the side pack doesn't have space for a cassette, but if for any reason you kind of want to get two things done at once, kill two birds with one stone, you can get your real-time readings using the side pack, and then you can also get your lab analysis done if you use a personal sampling pump. So you can do everything together. Typically some people may do the real-time readings first to see if there even is a need for lab analysis. And you could just save yourself time getting both of them done at once as far as the sampling goes. So let's see here. Oh, yeah, actually I'll note, so I'm wearing a cyclone connected to the AM520 here. The AM520 has all these different impactors and they're meant to be used at 1.7 liters per minute, I believe. So if you're measuring respirable dust, the side pack does not have a PM4 impactor. It has a PM5. Not sure why, but PM4 is typically considered your respirable. So in that case, you would use the blank impactor on the side pack and hook that up to a cyclone, and the cyclone is going to do the job of separating out your other particulates. So then you'll get your real-time reading of respirable dust. All right, and yeah, here's a picture of those impactors. So you can see there's the plastic piece that gets screwed onto the side pack and where you would connect tubing. And then there's the small impactor discs that go inside. So you just put a little drop of oil on those, install them on the side pack, and then you're ready to go. So important to note too, if you're not using a size selective impactor, then you should not be using that impactor disc. So if you're just measuring total dust, you're going to put a blank impactor on, and there's not going to be one of those discs behind it. Again, the mention of the 1.7 liters per minute to ensure that those impactors or cyclone are working properly. Okay, any questions on the dust monitors?
Jordan, I'm trying to follow. So like, would I use if I wanted to do respirable, would I use an impactor or a cyclone? Or it would be an either or?
So that's kind of the tricky thing to me is, like, I'm not sure why they have a PM5 impactor, because typically PM4 is irrespirable. So, if you were asking me, hey, I need to measure respirable dust, I would suggest using the side pack in this manner with the cyclone and with a blank impactor.
That makes sense.
Yeah, and that'll get you your PM4 measurements basically. Or you could get your PM5 with this, but technically it's, you're getting some particulates above the respirable size then.
Well, then I had a question.
Mm-hmm.
With the dust trackers, since it's more of a larger particulate, do you have to switch out say any of the tubing or really any of the gear that intakes it? Is that something you have to switch out regularly, since it might get any dust in there from previous measurements or anything like that? That's something you have to do, or no?
So typically the DustTrak is used just in an area setting. There's usually not tubing hooked up to it. So you can see in this picture on the right, you can see the inlet cap that's installed on it. So all the dust comes in through that inlet cap. There is a zero calibration that can be done by the user. So there's a zero filter you put on the inlet and you can do the zero calibration. That's going to make sure that you get your baseline of zero to make sure that you're not getting negative readings or readings above what they should be when they should be zero. And sometimes that calibration can fail. And that can fail due to a number of things. It could be particulates that are stuck in the mirror, which the way that the DustTrak works is basically there's a laser and the laser's aiming at this mirror. And so any dust that gets in the way of that, it's a light scattering photometer, that's what the technology is called. So, if there is any particulate in the way, or if there's any particulates that are maybe stuck on that mirror or in the optics that are in front of that laser, you'll fail that zero calibration. And that's when you would know if you needed to kind of clean things out in there. So we do that relatively often. So, if you guys owned one and you're in the field and it's failing that zero calibration, that would be what you could do. You could clean out those mirrors. You could try changing filters as well. And actually you see on the DustTrak here, there's see all those little indicators like filter, laser, flow.
Yep.
So that'll tell you if a filter is overaccumulated with particulates. It'll tell you if the laser's gone bad. It'll tell you if there's an issue with the flow rate. And any of those things can cause problems with your readings. But as far as, having tubing hooked up to it, it's not the most common. The only time that we see that is especially in our environmental enclosures. Basically, you've got a big case, that houses the DustTrak and some big external batteries. These are the things that go on those construction jobs for a long time, and those need to be in weatherproof cases. And there's non-conductive tubing. That's the important part. Non-conductive tubing that runs from the DustTrak into the inlet of where this DustTrak is going to be pulling air through the case. And that helps to make sure that, all this dust doesn't accumulate on the tubing too much. I'm sure if you've done air sampling, you'll see, people use Tygon tubing. That stuff can get dirty. You'll get particulates that are noticeable on the inside of the tubing. Those you definitely, you would replace those, right? But with the DustTrak, it's not too common to have tubing hooked up to it. So I guess that's kind of like the super long answer to your question. If that answered it. Was that it? Was that good?
No, yeah, that was pretty good. Thank you.
Okay. All right. So back to, all right. Yeah, we'll move on to our particle counters. So everything I was showing you before, your DustTrak, your side pack, these are all measuring in milligrams per cubic meter. And this, the P-Track, also made by TSI, this is a particle counter. So it's just going to give you, a count of particles per cubic foot, or I think per liter. It kind of just depends what you're doing. Again, that's a unit that you can set on the instrument. In the P-Track, this one's just specifically for ultrafine particles. So pretty much anything smaller than 1 micron. And they're most often used in like clean rooms, checking fume hoods, making sure there's no leaks in those, combustion leaks, a lot of different stuff. All right. And then there's videos on this too. You guys can maybe just watch that afterwards, but it's a little confusing sometimes with TSI equipment, what software it uses. So your P-Track, your DustTrak, your VelociCalc, otherwise known as the Q-Track, it's going to use Track Pro 4.7.2, point whatever really, but 4.7. Track Pro 5 is a newer version. It's only for the AM520. And that Q-Track XP we were talking about earlier, that uses Track Pro Ultra. So there's also Track Pro Lite for a different particle counter. But, you've got all these instruments using 4 different softwares. And I think eventually what TSI is planning is to have Track Pro Ultra encompass all of this equipment. But for now, you guys may see, depending on the equipment you're using, you might be using different software. It's just something to take a note of, I guess. In the rental business, we get a lot of people asking us, hey, how come my software is not working? It's just because you're using the wrong one. So simple little tip. Okay, now we can move on to noise. So the most common thing that we have is the TSI Sound Pro. This is pretty much the most advanced one that they have, to my knowledge. It's going to get you tons of different data. It does have octave band capabilities as well. So if you guys are doing octave band analysis, this does have 1-to-1 and 1/3 octave band capability. And of course, there is a field calibrator that'll come with it. So you can do field calibrations at 114 decibels, data logging parameters, again, kind of as you please, one every second, every 5 seconds, every minute, totally up to you. This is a good little gotcha here, the L average versus LEQ. So sometimes people know, for their job that they want L average, and then they go and they do the sampling and they're getting LEQ data and they're wondering, hey, where is my L average data? So it really just depends on the settings that you use. What's important to note is that they're functionally equivalent. They're really the same measurement, but you're just getting a different name for it based on the settings. So the LEQ is ignoring a threshold. So I like to think of that as, the L equivalent, the real sound, because it's ignoring that threshold. So if it's not utilizing the threshold, then it's taking into account all of the noise that was underneath that threshold of, let's say, 80 decibels. The L average is going to ignore those sounds and basically consider them 0 decibels. So you're going to get higher numbers, most likely, for an LEQ than you would for an L average.
Jordan, could you explain a little bit more about L average and LEQ with regards to I thought it had something to do with the period of time that was sampled.
Let me pull this up in the manual here, because I always forget it. And there's a good explanation here in the manual. Let's see, LEQ. All right, we're gonna go down to here. And then L average. All right. So everybody sees this now?
Mm-hmm.
Okay.
And by the way, I actually do use this manual quite a bit.
Oh yeah. DMS, there's a lot of things you can do in there, a lot of variables. You know, never hurts to brush up on it. So,
Oh,
yeah,
okay. It's both. They're both over the runtime. Okay, that's what I was
Mhm.
getting at.
Yeah,
Oh,
so it's not a time-based thing. It's really just the settings. So LEQ is only used when the exchange rate is set to 3 decibels and the threshold is set to none.
okay.
If you don't have those settings, you're going to get L average. But again, they're functionally equivalent. It's really just, you know, the settings are different, and so they call it LEQ because it's basically taking everything into account since you don't have a threshold. That's the way I look at it.
That's helpful.
All right. Let's see. Oh, there's also a CNEL setting. So you can get readings. This is more towards, you know, community noise exposure. So where they're sampling overnight as well. The CNEL is going to boost those readings to account for the quietness of the night. So, you know, we all know there's not as much going on at night. So any sound, you're going to hear that much more clearly than you would during the day. So the CNEL setting takes that into account, which is kind of nice on the Sound Pro.
Jordan, another question on
Mhm.
the noise monitor. So as I remember, these sound level meters are measuring sound pressure and not power. Is that correct?
Yes. Yeah. Well, as far as I know, anything that's measuring sound is measuring the pressure.
Right. Okay.
All right. So, yeah, there are Type 1 and Type 2 microphones available for the Sound Pro. A lot of people do not know the difference between Type 1 and Type 2. Type 1 is just more accurate. Type 2 is not quite as accurate. In general, people will tell you, you know, Type 1 is accurate plus or minus 1 decibel. Type 2 is accurate plus or minus 2 decibels. That does change among the entire frequency range, though, so it's not exactly linear. But if you happen to be involved in any sort of litigation, you're going to want a Type 1. Type 1's more accurate. That's what they're going to want. So that's something important to know for the future. The Sound Pro does have different weightings you can use. There's A, C, and Z, which are more common. And then F weighting, which I could not find any information on other than in the Sound Pro manual. So that's one you probably won't deal with much, but A, C, and Z are pretty common. And there's two what they call virtual meters for measuring. So, you know, you can kind of have two different sets of settings to get different readings, which if you guys, have they used the Edge 5s for noise?
No,
No.
we've got the Quest sound level meter and I think the Casella dosimeters.
Oh, the D badges?
Yes, the D badges.
Okay. Yeah, well, I think those two, they have, you know, what we would call like virtual dosimeters. So different settings for different regulations running at the same time. So then you kind of have data, like for example, the edges, which I'll probably go over in a couple of slides. There they are. They have 3 virtual dosimeters, but let's see. Just a little brush up on the weighting. A weighting is the most commonly used, and that's adjusting the measurements to reflect the sensitivity of the human ear. C weighting is going to focus more on low frequency sounds and is often used for measuring peak impulse noise measurements. The Z weighting is flat frequency. So that's, I guess, what you consider the actual noise. There's no weighting, and that's often used in octoband analysis applications in determining environmental noise. There's the F weighting, also a flat frequency response, but just has like a little bit higher curve than the Z weighting. So like F weighting is basically, if you see the Z weighting, which is flat at 0, I think the F weighting is you know, at like the 10 decibels and it's flat. Okay. Yeah, here's just a few different pictures of what you could see on the Sound Pro. So there's like the sound level meter view, or the SPL, which is just basic. It's just giving you your decibel level. Then you have the octave band displays. So there's your 1-to-1 and your 1/3, which shows much more detail. But you can cycle through these views using that. There's these 4 soft keys on the instrument. There's 4 black buttons there, and underneath each logo, that's what the button corresponds to. So that little glasses logo is how you can kind of cycle through the different views that you have here. All right, so now we can move on to the edges. These are personal noise dosimeters. This is one of our most common pieces of equipment. We consider them like our French fries, if you will. So they are type 2. Most dosimeters, if not all, are type 2. I don't think I've ever heard of a type 1 dosimeter, but there could be one out there. So we do carry the D badges as well, but just highlighting the edges since they make up the bulk of our fleet here. So they came out with the Edge 4 Plus a couple of years ago, and during COVID, this was kind of something we wanted to feature a little bit due to the Bluetooth capabilities. So there's an app that TSI has. It's called the Edge DB app, and via Bluetooth, you can monitor the dosimeters in real time. You can get your data from there too. You can start the dosimeter, stop the dosimeter. It's just, you know, a nice little thing to have for some people in the field. Some people like it, some people don't care about it, but it's got the capability there. The important thing to note, aside from the Bluetooth capability, there's the Edge 4 Plus, and then there's the Edge 5. The Edge 5 is intrinsically safe and can be set up with 3 virtual dosimeters. So by default, it's going to be measuring your OSHA hearing conservation levels, your OSHA PEL levels, and the ACGIH. So intrinsic safety and 3 virtual dosimeters on the Edge 5. On the Edge 4, you only get 2 of those virtual dosimeters. Now, they are user defined, so you can go into the software and adjust these settings however you'd like. Just know that you can only have 2 sets of that. They are also not intrinsically safe. So if you are going somewhere and you need intrinsically safe equipment, you cannot use the Edge 4. You're going to need that Edge 5.
Jordan, I have not defined intrinsically safe, or I have not talked about what that means.
So intrinsically safe really just means that it's safe in an explosive environment. So the instrument itself is, you know, let's say that there's some sort of explosion or fire or something. Edge 5 is intrinsically safe. It's not going to explode due to exposure of this. You know, I guess you could say it'll probably just melt away, right? But some things are not safe in that way. And basically, if you're going to an area that has the possibility of becoming an explosive environment, you know, I'm not really sure exactly like of examples of that. You know, I'm sure some sort of manufacturing processes could have something where that would be needed. You know, I would say most of our customers, that question's not brought up often. And, you know, I don't think people find themselves in a situation very often where they need intrinsically safe equipment, but it's just something to be aware of, really. You know, if
The example that comes to my mind is if you're doing a confined space entry where there, or maybe more likely a rescue, so suppose where there might be an upper explosive limit and you've got other equipment on.
Yeah, definitely. So all our gas monitors, those are intrinsically safe. And, you know, that I should have thought of that. That makes perfect sense. You know, edges or noise monitoring, you're probably not going to be doing down in confined spaces too often. So you may not find that, but there's going to be a situation at some point when it comes up So you're gonna just want to know, about the differences here and what intrinsic safety means. All right. So this calibrator here with the Sound Pro, the little AC300 there in the middle of the picture, it has a little adapter on it that can be interchanged to fit whatever you are using. So the edges can use the same calibrator as the Sound Pro does. Again, it uses the same software, the DMS, detection management software. Unlike most things, you cannot change the data logging interval on the dosimeter. So the edges log every minute. Once you start the dosimeter, it's going to start logging. Once you stop it, it's going to stop logging. So you can view the battery life in real-time data on the screen. So these are all the things that you can see if you just cycled through the dosimeter. And oh yeah, looks like we kind of focused on that stuff here. We actually have some video showing you how to use the EdgeDB app and how to use the Gillian app, which I forgot the name of it. Might be Gillian Connect or something. Probably find out. Oh, no, I just had the video. So yeah, if you guys want to watch that video, you can learn a little bit about what you can do with the Bluetooth apps. And those are on, pretty sure they're both iOS and Android. I wish I remembered the name of the Gillian one, but it's in that video, so. All right.
Wait, so that's news to me. So if I'm running my dosimeter, I can remotely watch it off of my phone.
Yes, you
Well,
just
that's
need to
amazing.
be, yeah, you just need to be close enough to have the Bluetooth function work, because Bluetooth can only work in, I mean, roughly 50 feet. It kind of depends on how much stuff there is between you. If there's several walls between you and that dosimeter, it may not stay connected. So you do need to be relatively close. That's the only hang up to the Bluetooth.
Okay.
Yeah, but you can do that with the edges and the pumps, and that video can show you a little bit more about it. All right, so rotometers. If you guys are doing any air sampling, you may have come across this already, but the rotometer is just measuring the flow rate. It's considered a secondary calibration standard. So, more of a qualitative, I guess you could say. The rotometer needs to be calibrated to a primary standard at least annually to ensure accuracy. So a primary standard is going to be something that you actually send to a lab. Whoops. You get a NIST traceable calibration certificate for it. These are the things that you need to prove that this is reading correctly. So yeah, this is a rotometer, and this is kind of what you could call the calibration. So you can see, for example, at 1,000 milliliters on this, in reality, it's 971 milliliters. So there's variations between what this was showing when it was first purchased and, after it's gotten lots of use. So you can use these little tables to account for those changes. And these are the primary flow calibrators. So this is a BIOS Defender. You may have heard of these before, like the 510 or the 520. They do have different options for them, like a medium flow, a high flow, a low flow. Just depends on what you're doing. And then there's a TSI 4146. That one's pretty much good for like 0 to 20 liters. So this one's pretty versatile. There is one little thing though, which you can pick up just from looking at this picture. So you can see that the caps are on the TSI calibrator on the right side, the 4100 series, and yet it's still showing a reading. So this is something that some of our customers have brought up, something we've noticed. Basically, if you're running at very low flow rates, The 4146 may not be the best bet just because sometimes, this should be reading 0, right? There's no air flowing through it. It's capped off on both ends. So some people may not have so much trust in that reading if they're sampling at, let's say, 0.01 or 0.02 liters a minute, because it's reading 0.01 as it is. The Defender, on the other hand, it's not going to give any reading until it detects the suction from the pump. So it's just a little more confidence in that at times, but otherwise, they're both great instruments, both great pieces of equipment.
Jordan, is one a mass flow meter?
When you say mass flow meter, what do you mean?
I was thinking that the Gilair Plus was based on mass flow instead of like velocity, or maybe I'm mistaken.
They're probably, good question. Are they mass flow or velocity? I think they are mass flow, but that's, let me write that down. Let's see, calibrators.
Or I guess it would be mass flow or volumetric flow rate.
Mm-hmm.
Yeah.
Yeah, I mean, because at the end, the cool thing, the Gilair Plus gives you like a volume sampled.
Yes.
These can data log. So yeah, it's volumetric. It's mass.
And then
Okay.
the other question I had about it is, those are primary standards?
Yes, these are primary.
Wow. Okay.
Yeah. So these, we send, I mean, technically it can't be considered a primary standard anymore if it's not within, NIST traceable calibration. These things should be calibrated once a year. So technically it's invalid after that year, which is why we as a rental company, we send all our equipment to be calibrated annually. And that's just to ensure accuracy and ensure confidence in our equipment with our customers. They want that piece of paper that says this is reading correctly. So that's really what makes it a primary calibration standard. Okay. So yeah, the TSI 4146, one of the good things about it, and that's the one on the right side here, it's just easy. So there's no menus to go through. It's really just you turn it on, you hook up your sample train and run the pump in the calibration mode. In that calibration mode, the process of calibrating a Gilair Plus, there's a video on that a couple slides back. It also has a smart cal cable, so you can actually hook it up if you have your pump on a dock. You can hook up the calibrator to the dock, and there's a way for it to kind of calibrate itself. So you just say, hey, get to this flow rate, and it does it for you. It's pretty cool. I've never done it myself, but I saw a video of it once. Again, the flow rate on the 4146, 0.01 all the way up to 20 liters per minute. Some people will refer to these units as liters per minute or cc's or milliliters. There's kind of your little chart, cc's and milliliters are the same, interchangeable. And then of course, 1 liter is 1000 milliliters, which is 1000 cc's. The 4146 does come with this dampening module, which is pictured at the bottom here. It's meant for use with systems that do not have internal dampening chambers. And what those do is reduce flow pulsation. Most modern sampling pumps have that though. So if you're using a really old pump, you may want to use this dampening module. But for example, the Gilair Plus has that internal dampening. You do not need the dampening module, but it'll come with it if you happen to rent one or buy one. All right, and here's a little diagram just of how it gets set up. There is a filter, just a little particulate filter that goes in here. That's to make sure that the pump isn't pulling all of these particulates into the sensor of the calibrator. Then you get problems with your calibration, and maybe even need to send it for repair. So you've got your filter here, your calibrator, your tubing, your media, and then your media hooked up to your pump. Just kind of a basic setup there. All right, and then we have the BIOS Defender, the 520. So a lot of different models in different modes. So there's single mode, continuous mode, and burst mode. That's basically, how many times it's taking this measurement for you to calibrate your flow. The single is just going to take a measurement and stop. So I wouldn't recommend that. I like to do the continuous. It's basically just going to keep running in sets of 10, and it's going to give you an average as it takes those measurements. So it'll take, let's say, 5 measurements. It'll show you the average of those 5. And it just goes into sets of 10. So that average will keep changing as it continues to take those measurements. The burst is similar, but I like to just go with the continuous. It's the easiest one. Whoops. All right, and then I think I mentioned this before. There's a low flow model, a medium flow, and a high flow. So, try and pick the one that fits your application the best. It does also measure temperature and pressure. So you can record temperature and pressure with the BIOS Defender. It also has leak test diagnostics to check the functionality, make sure there's no internal leaks, and that you're not getting bad readings on the calibrator. Another interesting thing is that it has 2 different ports, one for pressure and one for suction. So if you happen to be trying to calibrate, I don't know, a regulator that's pushing air, I've never had anybody utilize that feature that I know of, but just another little thing that the Defender can do. Okay. All right, so when you're doing this sampling, common practice is to measure your flow rate, or calibrate before you sample. Make sure you're at the right flow rate before you sample, and then do a post calibration. So you want to make sure that that flow rate after you're sampling is within 5% of the initial flow rate to ensure that that sample's valid. If it's outside of that range, you may want to think about voiding that sample. Again, just those flow rates are really important, especially if you're using cyclones. You're not going to be getting the right, what they call it, the cut point, which is essentially, how these cyclones are separating out your particulates. If your flow rate's not good, your separation of the particles isn't good. So you want to make sure that that is as close as possible to the proper flow rate. And again, kind of like I mentioned before, using that Defender, you definitely want to record that flow rate at least 5 times and take the average of those measurements. So that's where the Defender comes really in handy, because it's constantly providing different measurements, whereas the 4146 is really just a number on the screen that's changing. So you're not really taking multiple measurements, just kind of holding that number. And of course, when you do calibrate with your sampling train hooked up. So you don't want to hook up the pump directly to the calibrator and call it a day. You want to mimic exactly what you are sampling. So hook up the pump to the tubing, hook up the tubing to the media, and then hook up the media to the calibrator. That's essentially what we're trying to do with that. Okay, yeah, so a little bit on the accessories like the cyclones I mentioned. Those are using centrifugal force to remove specific size fractions of dust. And if you're using a higher flow rate, you're usually going to have a shorter sampling time. Like I mentioned before, flow rate is extremely important. You want to make sure that that's calibrated properly. Make sure that your tubing is mounted in the breathing zone of the employee, since that's where they're actually breathing from. You don't want to take your measurements from down at their waist, because the level of particulates is going to be different down there. And on the cyclones should be worn vertically and hang loose. So if the cyclone's tipped over, the large particles from the grit pot can pass through to the filter, and that it's going to drastically affect the weight of your sample. And the grid pod catches all the larger particles. So everything that's not going into that cassette is going to fall into the grid pod. And if that tips over and goes into the cassette, that's when you've got a big problem. All right, whoops. So yeah, here's just a few of the cyclones. This is a GK 2.69 cyclone that's made by Sensodyne. And this is definitely for your higher flow rate applications. So that's respirable dust at 4.2 liters per minute. And then we've got a couple more. That old style door Oliver on the right side. Actually, it's a newer style door Oliver, but 1.7 liters a minute for that, just like the side pack. And then we have this aluminum cyclone in the middle. That is 2.5 liters per minute. So again, depending on what your job looks like, what the application is, how long these people are doing the work where they're exposed to this dust, that's going to help to decide which cyclone and which method that you're going to be using for sampling. And that is it.